Chapter 2 notes. We are beginning Chapter 2 now. We will be studying multiple representations of linear equations. What that means, basically, is that we'll be looking at situations that result in the graph of a straight line. And we will represent these situations in four ways. If you look at the diagram below here, sometimes we'll be given a situation that is linear, like someone is earning $5 per hour, or they're driving somewhere 60 miles per hour, or they're saving $50 a month in their savings account. But it's a situation where whatever is changing at a constant rate. So it's always increasing or decreasing by the same amount. We'll be able to write an equation to represent that situation. We will be able to fill in a table that represents that situation. We've dealt with tables before already. And we will be able to make a graph of the situation. And then as you look at this diagram, you'll notice there are arrows going every which way. The goal at the end of this unit is that you could be given any one of those four as a starting point, and you should be able to come up with the other three and move between them pretty easily. So that's what we mean by multiple representations, that we'll be able to take one situation and represent it in four different ways. Here is an example. At the bottom of the diagram, it says we'll start with $3 and save $2 a day. So there's a starting point, $3, and then we are adding $2 a day to that amount. So on day one, after we've added $2 to it, we would have $5. And after day two, we would add $2 to it, we'd have $7. Now, notice, you can kind of see where things are coming from. Starts with 3, that's part of the equation. If you look up here, when the x is 0, that's often called the starting point. And if you look on the graph, that's part of the graph. So this starts with 3, shows up in all four situations. Now the saves $2 a day, that shows up in the equation. That shows up in the table. Okay, and that shows up in the graph as well. So that $2 a day shows up in all four situations as well. So that's what we'll be doing, is taking, this is a concrete example, where I might give you an equation and ask you to come up with a situation. I could give you a graph and say, can you come up with a equation? I could give you a situation and say, can you make a table? I could give you the equation and ask you to make the graph. So we're gonna have to be able to move between all of these. One last example. At the bottom, you'll see some tile figures, we call them. And this is just another way to represent a linear situation. So if you count these tiles, notice there's 3 tiles in figure 1, there's 5 tiles in figure 2, there's 7 tiles in figure 3. Okay, so notice figure 1 has 3 tiles. That is a point in the table. It is also a point on the graph. And if you plug a 1 in for the x, representing figure 1, it'd be 2 times 1 is 2, plus 1 is 3. So, as you can see, these are all interrelated. Figure 2 has 5 tiles, okay, which you can find in the table, which you can find in the graph. Now, interesting, the starting point, that 1 on the outside of this equation over here, which is also the 0 point here, and you can also see it on the graph. There is no figure for that one, but you could figure it out, like where's figure 0? Notice we're subtracting 2 tiles every time if we go backwards. So if I took 2 tiles off figure 1, I'd have 1 tile. And if you look at the equation, that's the plus 1. So this is just another representation. But this is what we're going to be studying and what we're going to be learning how to do in Chapter 2. Now, our first assignment is just going to be kind of diving into these linear equations, and we're going to be starting with an equation and making the table, and then going from the table to the graph. So we've done this before, plugging in values into an equation and then evaluating it. We did it in Chapter 1. So basically, you're going to take the x value and plug it into the equation for x. So it'd be 3 times negative 2. Remember, when we plug in something, we put it in parentheses. And 3 times negative 2 is negative 6. Then we will plug in negative 1 into the equation. So we have 3 times negative 1 equals negative 3. Fill it in the table. Plug in a 0 into the equation, etc. You may notice there's a pattern forming now. From negative 6 to negative 3 is adding 3. From negative 3 to 0 is adding 3. Plug in a 1. I get a 3. That's a 3. If you'll notice, we're adding 3 every time. So this one will become 6. And you can plug in the 2 if you want. That increasing by 3 every time, that shows up in the equation. If you look carefully, there's a 3 next to the x. Okay, so we'll be looking for connections like that. Now you can simply graph those points on the graph to the right. So negative 2, negative 6 would be down here. Negative 1, negative 3 would be here. 0, 0 would be here. 1, 3 would be here. And 3, 6 would be here. Now, we can connect these points with a straight line. And when we do that, we want to put arrows on the end of it. And I'm not great at drawing that freehand. But if we did it right, all those points should line up in a straight line. So we just took an equation, made a table, and then we made a graph. That's 3 of the things in our multiple representations diagram. Now, we will learn faster ways to do these, but that takes care of 3. Here's another example. Again, we're just plugging in x values into the equation. So I'm going to take negative 2, plug it in for x. I'd have negative 2 plus 3, which is 1. Then I plug in negative 1. I'd have negative 1 plus 3 is 2. Plug in a 0. I'd have 0 plus 3 equals 3. And I think you can see the pattern. It's going 1, 2, 3. If you plug in a 1, you'd get a 4. Plug in a 2, you'd get a 5. Notice it's increasing again by 1 every time the y value is. And if you look up here, what is in front of that x? Well, that would be a 1. We can graph these again. So negative 2, 1 would be here. Negative 1, 2 would be here. 0, 3 would be here. 1, 4 would be here. 2, 5 would be here. Again, if I've done this correctly, they should form a straight line. And you want to connect them, put arrows on the end. We usually draw the graphs to the edge of the graph paper. Here are 2 more examples. Again, you're going to plug in negative 2 into the equation. Here we got to be careful because we're going to be multiplying 2 negatives together, which makes a positive. So I get a 5. Plug in negative 1. I'd get 2 plus 1 is 3. Plug in a 0. Be 0 plus 1, which is 1. And you can probably see the pattern already. It's going from 5 to 3, 3 to 1. It's losing 2 every time, subtracting 2. And again, I think if you look in the equation, you can see that happening. So the next one would be, if I subtract 2, I'd be at negative 1. If I subtract 2 more, I'd be at negative 3. So now I can graph those. Negative 2, 5 would be up here. Negative 1, 3 would be here. 0, 1 would be here, 1, negative 1 would be here, and 2, negative 3 would be here. Connect those with a straight line, and we know we're correct. Now, if you were graphing these points and you ended up with a point like, let's say, here instead of here, you would know you did something wrong because the points weren't all lining up. So that's a good check. All the points should line up in a straight line. Now, this last example is kind of interesting. It says y equals 3. There's no x in the equation. So when I go to plug the x in, there's nowhere to put it. So that means the answer when I put in x of negative 2 would just be 3. When I go to plug in the negative 1 for x, again, there's nowhere to put it. So the y must still be 3. And in this case, it's always 3. So now when I graph these, I get negative 2, 3, negative 1, 3, 0, 3, 1, 3, 2, 3. This is again a straight line. Okay, but this is a horizontal line. Okay, so lines can be horizontal. They can also be vertical, which means they go up and down like this. Okay, can you guess what the equation for a vertical line might be? Well, if horizontal was y equals 3, vertical is x equals 3, in this case, since it goes through 3. All right, good luck with drawing graphs using tables. Vertical